Okay, today we're going to talk about this Kenmore refrigerator. We're not going to go through every detail of it. We're going to talk about the schematics. We're going to talk about some of the diagnostic modes, how you're going to use the diagnostic modes for troubleshooting, and when you're looking at some of the things on this schematic, what it is exactly you are looking at. Okay, yes sir. He just went to sleep. It sat idle for so long. But one thing you want to look at is this rectangle right here, and I'm going to scroll down to the bottom of it. That whole rectangle here is the main computer for the refrigerator. This is located on the French door refrigerator. This says Sears Kenmore, but this is the same as the Frigidaire Electrolux brand unit. Their main control board is located on the bottom below the door. You have to take off the front grill, and that board's a little bit to the left hand side, and you can pull it down and pull it out to get to the components. And if we look over here to this little box right here, this is that main control board. All right, and what we have here is J3, J2, J1, and then we have some other plugs, J5, 7, and so forth. If we look at this schematic right here, notice that this says J4, J5. J5 is the connector on the board. They're showing you here where you'll find that connector. Like this is J1 here. If I scroll up, let me find J1. J1 is right here, and it has 3 pins, neutral, ground, and line. And then if we look over here, if we were looking physically at the board, you have 1, 2, 3, 4 here, but that is that plug, J1. Yes?
Oh, I was just going to say, I saw another J1 down there as well. These can scroll right up, a little bit more up. You see where J2's at?
Right here?
Down on the bottom, right there. That also says J1.
Well, why do you think it says J1 there? Why does it say J1 here and J1 there? Anybody have any idea? I'm glad you pointed that out. Well, one second, Dudley. Let's keep looking. Do you see any more J1s at all besides those 2 that you pointed out?
I thought I saw another one up there, but I could be wrong.
I can say like that's a double plug.
It's not a double plug.
That's a
Would it be a component that communicates to J1? That's just
Not that it communicates to J1. Yes, Dudley.
That's the line or the wave that completely load up a certain particular.
No, let's take a look at something here. If I look at this, I know it's a little bit blurry, but this is J1.
Yeah.
This is pin 1, pin 2, pin 3, and pin 4. Those are exactly the way you'll see the plug on the board and where each number pin is. So how many wires are on plug J1? 4. 3 of these wires are the power cord coming in. This is the actual plug, this is ground, this is neutral, and this is line 1 coming in. The 4th wire on that plug is right here. It's part of that plug. They're not showing you them all together on this diagram here. They're showing you all together on the other diagram there. But the 4th one goes over here to this freezer, evaporator, heater, and a thermal cutout. So that 4th wire, which is pin number 4, is the top right pin here, this number 4 right here.
So it's basically coming in from the power itself, and it's providing power to not
These 3 wires are providing main power to the whole board.
Exactly.
That 4th wire doesn't have nothing to do with main power. That 4th one has to do with the defrost on the evaporator. Okay? That's how you have to look at it. So the first letter, like J31, is plug J3, the first wire on that plug. So you go over here at J3, they have a number 1 at the top, so that very first pin right there is that wire right there. I have a J32 over here, so the second pin is over here, and it controls the ice maker evaporator. You follow me? As far as location? So you need to know if you're going to do tests on the board or on the diagram, how do you find them on here? Well, this is showing you what those pins control electrically. This is showing you where they really are on the board and where you're gonna put your meter. If you're gonna test J32, I'm looking for J3, it's this big long one here, and it's that second one. That pin right there is that wire right there. Okay? So, let's go a little bit further down. Now this diagram was put together, was scanned in such high resolution, I had to scan half of it and then the other half and put the diagram together, so that's why you see like a line here. But this line is factory, and it says AC and DC side. So part of this control board has AC voltage, alternating current, and the other half of it is DC, which is direct current. Alright? So all the components over here are running off of DC volts, and we'll talk about that in a minute. All the components over here are AC volts. Okay? We got the power supply coming in, we have a compressor here. I got a question. This is a compressor, right? Then, what is that?
Smaller compressor.
It's another compressor. This refrigerator got two compressors?
No.
No?
No.
So then what does it have?
It's for the freezer.
Nope.
That says compressor control signal, or, 'cause I can't read that last one.
Yes, you're right. Compressor control signal.
So it's just basically a.
No, because this particular brand refrigerator could have one or the other compressor. Those of you who are familiar with refrigerators, you got a standard compressor with a relay and an overload. And if we looked at this diagram here, this will be the compressor, this is power coming in, the relay and overload would be here. That would be like a standard compressor, okay? The other ones would be a variable speed compressor. If it was a variable speed compressor, it would be running off of these wires here. Okay? So if it has an AC volt compressor, just a standard compressor, a non-variable speed, it would be on the AC volt side. If it was on this side, it'd be running off of there. This is the communication wires for it, okay? Let me see something here. That might be the inverter board for it. You're right. You know what? This is not a typical compressor. They're showing that compressor in two different things. I'm going to correct myself here. That you have two wires coming in, 110 volts. That's the inverter board, which is part of the compressor. This one is control signal. These two wires are these two wires here. So that is an inverted compressor. This is specifically for that machine, but there are some refrigerators like GE, they show two different compressors where it could have one or the other. So I made a mistake on this one. All right. So this here have 110 volts. This one is the signal. We're going to get into a little bit on how to test that stuff towards the end. We're not going to get into testing, so I made my mistake here. All right. So 110 volts AC comes in here. This is a low voltage signal. If we go down here to the other schematic here, what does that say right there?
DC.
It says +1 DC. So on pin J4, terminals 11 and 12, you can check DC voltage here. Why would I check here? What would I be checking?
Checking to see if the control signal works.
The control signal, but what does that mean, the control signal?
You control like how much power it goes to, how much power it goes to.
Not really, because I don't know if I can show both of them at the same time. Just barely, yeah, I can get it here. So what happens here is that there's 110 volts running to the inverter board all the time. All the time, okay? Even when the refrigerator reaches temperature and we want to shut the refrigerator off, we still have 110 volts here. But this control board is not telling that compressor to run. But when the main board sends a signal here, sends a signal to these two terminals, it'll send this voltage to that compressor, make that compressor run. Now when we check the signal voltage, we have multiple things to check. Sometimes there's AC voltage, DC voltage, and a frequency all in those same two wires. Okay? Yes?
I have a question in regards to that. I know that some of these refrigerators have vacation modes.
Have what?
Have vacation modes.
Okay.
Where all the components are turned off except for the compressor itself, correct? Or is it not?
No, the fans would still have to be running.
The fans will still have to be running and the compressor will have to be running as well, but technically not the display or anything like that for that matter, right?
I
Lights
don't know about vacation modes. I do know in Sabbath mode.
There's Sabbath mode, that I know too, but I heard that some of these units do have vacation modes.
Well, those modes reduce the amount of times the refrigerator's gonna go into defrost and some other things like that.
Okay.
So reduce the energy usage. You don't wanna shut some of these refrigerators off because mold will grow inside of them and everything else. But because this compressor is called a VCC, variable capacity compressor, when, like we just plugged this refrigerator in and it wasn't plugged in at the beginning, what are the temperatures here? 65 and 75 degrees, so it's not cooling down yet. Okay? But it's hot. We need to get this thing cold. We're gonna put groceries in here, we need to get it cold. So we want that compressor running at maximum capacity. So when this board has these sensors here, which is the freezer sensor, the fresh food sensor, the freezer evaporator sensor, all of them are telling the main board, hey, it's warm in there. So the main board's gonna say, it's really hot in there, compressor run full speed. Now, as the temperature starts to get colder and starts dropping, this main board is watching these sensors here and saying, hey, you know, it's about 38 degrees in the fridge. We want it about 36, 34, and the freezer's almost 0. That's a good temperature. Slow the compressor down. Not only slow the compressor down, but our evaporator fans and our condenser fans, our variable speed fan motors, they're going to slow down their speed. So we reduce the energy consumption that the refrigerator is going to use. And it's easier for us to get to what we call the set point. Because if everything's running max speed and you just want to shut it right off, it's a little hard to stop it right there. It's going to overshoot and make it colder than it's supposed to. So by having a variable capacity compressor, when we get closer to the temperature, we can slow the compressor down, slow the fans down, use less energy. And that's all by this signal voltage coming in here. We're telling the board, slow the compressor down. Now this signal voltage does not control our fans. Our fans are going to be controlled off the main board over here. We have our ice maker fan. Let's see, where's our other fans in here? You see the fans? It's a little hard to read this schematic, it's a little blurry. Condenser fan is right here. And that's the ice maker fan there. Let's see the other fan. Oh, here's the evaporator fan right here. Okay, so is this evaporator fan AC or DC voltage?
DC.
What?
DC.
DC because it's on the DC volt side. Look at these wires here. This is plus voltage number 8 and number 9 is ground. So we have 3 wires. What happens when we have a DC volt fan is we have a power wire and a ground wire, just like a battery, like a plus and a minus. So here's where we're going to check voltage to the fan. Number 7 would be what?
Signal.
The signal. What would that signal do?
Tell, like you're talking to it.
It's the board is using that 3rd wire to know how fast the fan is running.
So it's a sensor.
It's built into the fan, the communication between the fan and the board will know, hey, the fan's running real fast or the fan's running slow, speed it up or lower it, and that will be controlled by the voltage on pins 8 and 9. If I raise the voltage up, the fan's going to run faster. If I lower the voltage, the fan's going to run slower. So that's what that plug is here. If we look at the condenser fan, it says the condenser fan's not here. Where's the condenser fan? Here. This is AC voltage. So is that fan a variable speed fan?
Yes.
Yes, because AC.
No.
No.
It has one line coming in. What do you think this line is?
Neutral.
Yeah, if you follow back here, it comes to the neutral on the plug, right back to the plug. So if you look, everything that's 120 volts has one wire coming off the board, and then the other side of those components are going to the neutral side.
What about
So they have 120 volts, they run one speed, yes.
What about the other one going down?
It's just connecting the ice maker water valve and the dispenser water valve. They're all using this as a neutral. Because all those parts are down at the bottom and the back of the fridge. They're all connected to each other before they go back to neutral. So instead of having one wire from that fan go here, and another wire go all the way back, and another wire go all the way back, and another one here, another one here, they jump them all off each other to go back to neutral. So they just have one wire just jump off of all of them. Cuts down on the amount of wire that they use when they build the fridge. You say something, Ricky?
Is it common?
It's common, it's neutral, yes. So everything over here, you're gonna see neutral wires or power wires coming from the board. So usually what happens is line one will come in, goes into black here, and then the board will send power back out, like here. Let's say this is line one. This is line one. It's gonna come into the board, then the board's gonna go like this and send it to the condenser fan. And when it hits the condenser fan, it's gonna come back out neutral
Yeah, close.
and go back to the plug like that. So there's some sort of what? What will we find here?
The light one.
A what?
Is the light
What
one?
would be right here?
It's the board.
Yeah, but what would be on the board there?
Plug.
We talked about it yesterday.
I was gonna say transformer, but it's another word for it.
Not transformers.
Yes.
Yes. Relays. There'll be a relay on the board. Power coming into the board, this relay would send power back out. When that relay closes, that unit will run. So if we look here, and let me get my mouse here. Look at all these relays we have here. So power would come in to the plug, go through the board, come out one of these relays, and this relay is going to send power out to the fan motor.
Yeah.
So one of these relays will be a condenser fan, one will be the ice maker valve, one will be the dispenser valve, and the other components. And when you press a lever here, for example, and you're calling for water, well, when you press that lever, that's gonna send a signal to this board, which is this board here, and close one of these relays, and those relays are gonna energize those components. So when you do something with the board, we have another board here, which is called the user interface board. When I do something here, this board is gonna tell the main board's gonna close a relay, and that relay is gonna send power to something else. So we have multiple boards in here. This has another board for the ice maker. We look over here, this is the main board, but what we don't have is the user interface board. That's the freezer ice maker. I'm trying to find where the user interface board is. A little hard to see on this diagram here. I think this is our this is a
Should it be
damper.
AC or DC?
I don't know what the voltage is on that board. We have to find it. Here we go, right here.
DC. Yeah, current.
This is it says right here, user interface, dispenser paddle. So this box right here is the dispenser paddle, the second box down. This is the dispenser paddle.
Yes.
I press down on this, it has a 12 volt DC plug right here. This board it gets a signal from my dispenser, I'm closing a switch. This board is sending power on the DC side here, and then what's it gonna do?
The relay is gonna.
If I want water, it's gonna go to the board and tell the board, hey, turn on the dispenser water valve. So this paddle tells this board to tell that board, close the relay and send power to the dispenser. And you're like, okay, how the heck do I troubleshoot that? I press the paddle and now no water comes out. That's why we have diagnostics and communications within this boards that we need to see. Okay? You got a question?
Yes.
I can tell you were just ready to jump. Go.
Now, when it goes to J9, there's supposed to be a triac or relay, right? How does it turn on?
Well,
is it going?
this board may have triacs on it,
Right.
okay? Which is an electronic relay telling this board. These are communication wires here from this board. It sends power to this board. This board then turns on the relays, which were what we saw on the bottom there for the water valve.
How does the board know for which relay to open?
Because there's, on this board, it's got a computer chip, just like your home computer has a processor chip. And on the board, it has another chip, which is called a programming chip. And the programming chip says, if this switch closes, and it'll be completing a circuit, if that switch closes, close this relay and send water to the door.
Yes.
Or if the ice maker's running, it's got programs in it.
Right.
And the program is done by the factory on the main board.
Yeah.
It's almost like when you turn the computer on, how does it know what to do? When you see all those black and white letters come up, it's a program already built into the board. Okay? So, if we look here, let's go over some information on the board. It's going to be broken down into two pieces because I scanned it so big. Well, let's take a look at these error codes here. Oops, I didn't want to change pages. Let me go back to where we were. But if we look here, we got error codes, FZFF. What does it mean right here in these three little boxes right here?
Display.
Display, but what are they talking about?
Freezer.
And
Refrigerator.
No.
fresh food, which is the refrigerator. But what are they talking about? What physical thing are they talking about right there?
The display.
The display. So if we look at this refrigerator over here, we have a display on the left and a display on the right. This is the freezer display, this is the fresh food display. It's telling us the temperatures in the freezer and refrigerator. Now, we need this refrigerator for competition. It's been running for a while. Does it seem like it's cooling? Hopefully there's nothing major wrong with this machine, but it is dropping temperature, but not very fast. So we're gonna have to troubleshoot this one out before we even use it. But let's take a look now. Here we have information in these displays. What do you think that information is telling, and what are they telling you? How to use that display? If you look at it and you see OP in the fresh food display, okay? You see OP in the fresh food display, so you're looking here and you see the two displays. If you see OP on the right-hand side, okay, they're gonna say the sensor, the thermistor, is open, okay? So what do then? We go to the refrigerator
Do it.
and we find that thermistor and we test it out with a meter to connect it. So already, if there's a problem with this machine, the sensors in the refrigerator, the thermistors, we talked about thermistors when we did the dryer. We said that they are resistors that change value on temperature. The thermistor tells the board the temperature. If the thermistor failed, if they're going to put a bad thermistor in the refrigerator, what's going to happen? You're going to see a problem in the display. Display is going to show you open on the right-hand side or open on the left-hand side. If it's on the right-hand side, the thermistor in the refrigerator is bad. We have to go in the refrigerator. We have to go to that thermistor, and we have to test it out. If it says open here, then we go in the freezer, down at the bottom. find that thermistor and test it out. So for the competition, you guys gotta know where all these little sensors are. Now what if I get open on the fresh food side, and I go into the refrigerator here, and I find the thermistor, and I'm gonna put my meter on it, and I get a good reading? What do I do?
You go back from one, just go back with the one connected to it. The one that supplies the power.
Check and see if you got a broken wire at your harness was plugged up to that thermistor from the board.
Okay, so you wanna go where?
You will go back where you was at the board testing. The
No,
wire-
I say, it says open fresh food thermistor. I went in the refrigerator, I went to that thermistor inside the refrigerator. I see a little plug, it's connected. I unplug it, I put my meter on the thermistor, and I get a good reading. I get the reading the thermistor's supposed to read.
So-
Now what do I do?
You will check and see if you got power coming from the board to that plug down to the thermistor.
So we're gonna go where physically to make that test?
You have to test it where you are disconnected from the thermistor up to the board. And then whatever the
This
pin
board
is,
up here?
no, the board. It's not the main board, it's not
The main board, where's that board located?
It's at the
It's on the
bottom.
Down the bottom.
Right.
So let's go back to the other diagram for a second. So what we're gonna do is we're gonna go back to this main board, right? And we got the fresh food sensor right there. That's the same sensor that they said open. And we're gonna go to where?
J6.
J6, where? 11, 12. 12 says +5. So on 11 and 12, I could do one of two things. I could unplug J6. Now J6 has 12 wires, but look at this. There's only 5 of them here, 6 of them here. Somewhere else is the rest of J6. But I can look at this diagram here, and I find J6 is this one, no, 5, 6, it's one of these here. Let's say it's this one right here. I go to J6 and I check pins 11 and 12. I can unplug that, put my own meter on it, on the wires, and what would I be testing? No. I'm gonna unplug it from the board. I'm gonna go to pin 11 and 12 on that board. What am I testing?
Let's see if the electricity is coming out.
Test and see if you got a broken wire.
Testing the board, Mrs. Z?
I'm unplugging the plug.
Yeah.
I'm touching the wires. I'm not touching the board. I'm
Oh,
touching
touching
the
the wires.
wires.
Yeah.
What am I testing?
The
sensor. From the board.
Right, that's what I
Remember, the test I said just before, we're gonna go inside the fridge. We're gonna find that fresh food thermistor. We're gonna test it with an ohm meter. We're gonna get a resistance value that says, hey,
Right.
it says the thermistor's bad, but my meter says it's good. So now I'm gonna go down to the board, and I'm gonna pull the wires off the board, and I'm gonna touch the wires that go from here up to that sensor and say, am I getting a good reading? Because if I get a good resistance reading from down there, but my board still says, hey, that sensor's open. The sensor's not open, what's wrong?
The board.
The board's bad. Now, if I want, I can go to pin 11 and 12, putting the red lead on number 12 and the black lead on number 11. So I put my red lead here, and I put my black lead here, and I look for +5 volts. If I have 5 volts, it's telling me my board is putting out the voltage. But if I ohm it out, and I get the same reading from the wires, I unplug it, I'm testing the wires, that means I'm testing this wire and this wire. I'm not checking the board, it's not even connected to the board anymore. I'm testing the sensor, and my ohm meter says it's good, then everything here is good, but my board still says it's bad. My board is bad. Even if I have the 5 volts, if I have a good resistance reading, the board should be seeing it. The board's not seeing it. The board's bad. Just because it has the voltage, don't say that the board's good. Now, if I had good resistance from this plug, but when I get over here I don't have good resistance, what's wrong? The wiring harness.
Yeah.
No, if I went to the refrigerator, the first test we did was, we said we got an open fresh food thermistor. I go to this plug right here, and I say, okay, from here to here, thermistor checks good. I go down to the board, I unplug this, and I check here to here. I'm supposed to be checking this whole thing, and I don't get the same reading that I get here.
Broken wire.
Somewhere my wiring's bad. I have a bad wiring harness somewhere in the machine. Does that happen often? No.
What happens usually?
Could someone get a mouse or something underneath there and chew on one of them wires by the board? Oh, it happens. Roaches, they crap all over the boards.
Yeah.
They destroy boards. Yes, sir. What are you gonna say?
No, I'm saying what usually happens.
Well, usually either there was a poor construction on the wiring harness in the factory, may have worked for a little while, and over a period of time, moisture, corrosion, or a rat could get in there and chew on them wires looking for food and water. Okay? But if you're getting an open sensor, this is how you would look for it. You go to the sensor, go back to the board. Could you go to the board and then to the sensor? Yes. But more likely I would go to the sensor first and then go back down if the sensor tested good. Okay, but you have to know how to make those tests. First, you need to know where the thermistor is. If you don't know where the thermistor is, it takes you 25 minutes to find it. So you need, for those of you guys competing, you need to be a little more familiar where the component location is. Same thing with the freezer thermistor. We are dropping temperatures. Refrigerator side hasn't gone down yet, but it's taking a long time. I gotta make sure it's working. Alright, so we do the freezer thermistor the same way. We can check voltage off the board. If I want to do the freezer thermistor, where would I check and how much would I be looking for? Where would I put my black meter lead and my red meter lead? Where would I do it for the freezer thermistor? I go here and the freezer says open. I want to see voltage coming off the board. Where would I put my 2 meters? My meter leads, I mean. Come on, someone say something.
9 and 10. Freezer sensor. Is it
J6.
Okay, and then what color wire would I put where? Come closer if you need to come closer.
Can you read it for us?
No.
Okay. So
If I can read it for you, give you the answer.
So gray.
so you put one
Let's upgrade
one of
and
the black will be on 7 or 8 and the red will be on 9 or 10.
No, 9 and 10.
So how do you know which one go to which
Because
one?
7 and
What
8
numbers?
have the same color.
9 and 10. What color meter leads am I gonna put in 9 and 10?
Black with 110
Black is
Why?
gonna go where?
and 10.
Why?
That's a power.
black goes on
They have the
9.
same color, man.
What color on your car battery is red and what color in your car battery is black?
Positive.
Positive is what?
Red.
Red. What does it say